Chapter 9.2, exercises 13 through 26. And I think this video we're just going to go through 13 through 20. We're going to have a separate video for the 21 through 26 set. And we say chapter 9.2, we're talking about section 9.2 in our book, which has to do with expansions, how to do binomial expansion using binomial theorem. So you go to problem 13. Problem exercise 13-16, find the coefficient of the given term of the binomial expansion. And here it says x to the 11th, y to the third power term. And what this is going to look like is this when we work this out. We're going to get our numbers of terms correct. The first term we're going to get is in this expansion. If we expand this binomial, we're going to get x to the 14th, y to the 0. So I'm just not going to write anything, plus x to the 13th, y to the first power, which would be x to the 13th over y, plus x to the 12th times y squared, plus x to the 11th times y cubed. So this is the term we're targeting. And the reason I go through this exercise right now is to determine the number. When we have this NCR, we've talked about NCR, N choose R, which you see sometimes written like this with the parentheses. We put N at the top, which in this case we have the 14th for, and then we're going to have our 0, 1, 2, 3. So we're going to have 14 choose 3. And to write this in our binomial with this n factorial over r factorial times quantity n minus r factorial, we could do it like this with the 14 to 3. We could also put this in our calculator with the n. So anyway, we're going to find out what that is. The coefficient is going to be what we calculate it to be here. We'll go to our calculator, and I'm going to get a new page, new document. No, we don't want to save anything. And we're going to get a calculator and go to menu, probability, and 5 combinations, 3 combinations. Here we go. And we're going to have n. N is going to be 14, comma, and then we're going to put control brackets, control close parentheses, bracket. We're going to put our third term here. Term that's going to be 0, 1, 2, 3, 6. Fourth term, we're going to get 364. So we go back to our exercise. We're going to get our fourth term is going to be 364 x to the 11th, y to the third power. And when it comes to it, our coefficient is going to be this guy in front here, 364. So that is our answer, our coefficient. Coefficient, there we go. And let's go on to problem 15. Our x to the fourth term for this quantity x minus 2 to the 12th power. Well, what we're going to have is, if we look at it like we did last time, we're going to have, first of all, our x to the 12th term is going to be our 0, right? That's going to be our 0. And then we're going to have x to the 11th, x to the 10th, x to the 9th, and so on, 8th, x to the 7th, x to the 6th, x to the 5th, and x to the 4th. And then we're going to go x to the 3rd, blah, blah, blah. But 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be r equals 8. So we're going to have, we're looking at here is 12, choose 8. And what that's going to end up being for us is our x to the fourth, we're going to get our coefficient x to the fourth, and then we're going to have y to the eighth, so we're going to have here negative 2 to the 8th power, and then whatever coefficient we have here, we're going to multiply that coefficient by this quantity negative 2 to the 8th power, and we're going to get a really large coefficient. So let's go ahead and work that in our calculator. We're going to have 12 choose 8, and we go to our menu again, and probability combinations, we're going to go 12, comma, we're going to get our bracket here, which we get by pressing Control and 8. And we press that in there, we get 495. So we go back to our exercise, and we're going to get 495. And negative 2 to the 8th power, that's quite a large quantity here, so I'm going to put that in here, negative 2 to the power of 8. We could do that in our head a little bit. I'll just put it in here anyway, since we're here. We get 256. So 256 times 495, that's going to be our quantity. So 126,720. And it's going to be x to the fourth power. And I'm going to box in what our coefficient is going to be. And you can use the binomial theorem formula as well. To do that, it'll take a little more work, not much. If you go to create a page here, a quotient, we're going to have n is 12, and that's going to be factorial, which is going to be 5, which is going to be 12 times 11, and so on, over 8 factorial, probability 1, times 12 minus 8, and then outside we make this a factorial as well. Menu 5, 1, press enter, you get 495. So binomial theorem using the factorials. Okay, so that is our answer, confirmed another way. We'll go on to the next set here, which is going to be part 17 through 20, and in this case, this one here, 17, is use the binomial theorem to find a polynomial expansion for the function. And I'm going to write out what this looks like. We're going to have some coefficient times x to the fifth times this y thing here, negative 2 to the 0 power. And by the way, we're looking for everything here, aren't we? And then we're going to have plus some coefficient x to the fourth, and we're going to have negative 2 to the first power plus coefficient x to the third, negative 2 squared, plus coefficient x squared. We're going to have negative 2 to the third power, plus coefficient, we'll have x negative 2 to the fourth power, and then we're going to have plus coefficient, and we're going to have negative 2 to the fifth power. Now this negative 2 to the fifth power. All right, that shouldn't be too much trouble. Anyway, we're going to expand the whole. I know. Let's go ahead. We're going to have 5. We'll go ahead and pick one with 5. We go to Menu, Probability, Combinations. We're going to have 5, comma, and we'll put control brackets. We have 0, comma, 1, comma, 2, comma, 3, comma, 4, comma, 5. So 5, we have n is 5. We're going to have 6 elements or coefficients. When we calculate this out, we're going to get 1, 5, 10, 10, 5, 1. And we go back here. 1, 5, 10, 10, 5, 1. So let's go ahead and figure that out. That's going to be equal to 1 x to the 5th power. And then we're going to have negative 2 to the 1st power is going to be just negative 2. So we're going to have negative 2 times 5 is going to be minus 10 to the 4th power. That's 10 to the 4th power. And then, make that a little more neatly. Uh, 10x to the 4th power. There we go. Okay, our next term we have here is going to be 10 times negative 2 squared. Well, negative 2 squared is going to be positive 4, and times 10 is 40, so we're going to get plus 40 x cubed. And then the next one we have here is going to be our x squared term. We're going to get negative 2 cubed, which is going to be negative 8. Negative 8 times 10 is negative 80, so we're going to have minus 80 x squared. And then this one here, we're going to have a negative 2 to the power of 4, which is going to be positive 16. 16 times 5 is 80, so we're going to have plus 80. It looks almost like a multiplication. Plus 80 x to the 1st power, right? And our last one is going to be negative 2 to the 5th power, which is going to be minus 32. So this is going to be our polynomial expansion for this function. Okay, let's go on to problem number 19, which we have quantity h of x equals quantity 2x minus 1 to the power of 7. So similarly, like we did problem 17, we're going to have some coefficient times 2x to the what power? To the 7th power. And we're going to have negative 1 to the 0 power plus some coefficient times quantity 2x to the 6th times negative 1 to the 1st power plus some coefficient times 2x to the 5th power, and we're going to have negative 1 to the squared plus some coefficient of 2x to the 4th power, and we're going to have negative 1 to the 3rd power plus coefficient 2x to the third power, and we're going to have times quantity times -1 to the fourth power. I'm going to make a second line down here, which will be plus, what is that going to be? Some coefficient times 2x squared times -1 to the fifth power plus coefficient times 2x to the first power, which is just going to be 2x. I'll just leave that here. And we're going to have, I'll put 1 just for, and we'll have -1 to the sixth power. And plus, our last term is going to be coefficient. We're going to have 2x to the 0 power times -1 to the seventh power. And we have a 7 right here, so we go to n equals 7. So getting back here, let's see, probability combinations. We're going to have 7, comma, and we're going to get our bracket there by pressing Control, then close parentheses. We're going to put 0, comma, 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, comma, 7. And we have 8 coefficients here that we're going to get, which we get 1, 7, 21, 35. Going back, we get 1, 7, 21, 35, and this will be 35 here, and we'll get 21, 7, and 1. And writing this all out, let's get this. It's equal to, we'll have 2x to the seventh power times -1 to the 0 power. Well, we're definitely going to have x to the seventh power. That's not going to be a question, but how many of these x to the seventh powers are we going to have? Well, 2 to the seventh powers of them. How many is that going to be? Let's see, I think that's going to be 128, isn't it? 128.
Make sure that all teachers and support staff members are aware that we have a lovely representative with us today from Costco, Mr. Page.
128, so, and this is going to be times -1 to the first power. We're going to have minus, and that's going to be 2 to the sixth power, which is going to be 64 times 7. So let's go over here and put in 64 times 7. We get 448. I hope that's right. 448. X to the sixth. And then our next one's going to be 2 to the fifth, which is going to be 32. This -1 squared is going to be +1. So we have 32 times 21. So going to the calculator, we have 32 times 21. We get 672. So going back here, we have plus 672 x to the fifth. The next one with x to the fourth, we're going to have this -1 cubed is going to turn this thing negative, so we're going to have minus, and 2 to the fourth power is 16, so we're going to have 16 times this 35. So we go to our calculator, 16 times 35, we get 560. So we come over here, put minus 560 x to the fourth power. Next we go to the x to the third power term. We're going to get 2 to the third power. Well, first of all, -1 to the fourth power, that's going to be +1. And 2 to the third power is 8. So we're going to get 8 times 35. should be able to do that in my head, but I will not. 8 times 35, we get 280. So we come back to the problem, we'll put plus 280 x cubed. The rest of the ones we should be able to do in our head. The x squared one is going to be negative 1 to the 5th. That's going to be negative or minus. And then 2 squared is 4. So we're going to have 4 times 21, which is going to be 84 x squared. And then our last one, we have, not our second to last one, we have negative 1 to the 6th power. That's going to be positive. So we get positive. And 2 to the first power is 2 times 7 is 14. So we get 14x to the first power. And then our last term is going to be negative 1 to the 7th power times 2x to the 0 power, which is 1. So we're going to have minus 1 will be our last term, our 8th term. So this is going to be our polynomial expansion. I'm going to create another video that goes over, and just in case this doesn't get into the just in case it doesn't get into that last part, I'm going to try to move this thing over, make sure everything is visible in the video. Okay, so the next video is going to cover that last set, 21 through 26. And I thank you for viewing.